Hello everyone. Today I come to section 4.3, matrix operation and their applications. This is one of the way we can do to solve the system of linear equations, and matrix operation is really helpful with a big system that more than two equation and two variables. So I mean, for two equation and two variables, it still can apply on that and still really great. But if you have like more than that, like four equation and four variables, you're using substitution, elimination, something like that, it will be really a challenge. So I would like to come up with a matrix operations and application. Okay, so what is matrix? A matrix is a rectangular array of numbers, and a row in matrix is set of numbers that are aligned horizontally, and column is in the matrix is set of number that align vertically, and each number is an entry, okay, and sometimes called element of matrix. Okay, so by convention we use capital letters to name the matrices. And for example, down here we have three matrices. Say matrix A as 1, 2, 3, 4, and matrix B is 9, -2, 7, and so on there, right? So we can see that right now I have how many rows do I have? 1, 2 row for matrix A. And how many columns do I have? 1 column, 2 columns. So this is 2 by 2 matrix. And for B we have 1, 2, and 3 row, 1, 2, 3 columns, something like that. And C we have 1, 2, 3 row, 1, 2 columns, right? So so that's mean what I can state the dimensions for each matrix by row and column. Is for A gonna be what? Say row is 2 rows, and then column will be 2 column. B is 3 row by 3 column. C is 3 row by 2 column, right? So if I ask you about element in the first row of matrix B, you're going to look at the matrix B and look at the first row, and you will have 9, -2, 7, right? For second column in matrix B, you will look at the second column here, and you will say -2, -5, and 8. And if I say the entry 2, 1 elements of A, you're going to look as row 2, column 1. So that's going to be this number, which is 3. All right, so put 3 here. And then the entry 1, 2 elements of C, you will look as row 1, column 2. So that's going to be the number 3. So let me type in here second row and first column, right? keep in mind that's the first number is a row and the second number is for column, right? So okay, so the next one will be first row, second column. Okay. Okay. So you can go ahead and practice with exercise 4.10. You can pause my video to do it and then check with my answer. But you can see that for matrix C, it's gonna be if I ask you about elements in the second columns, you're gonna do 0 and 2, right? And the entry 2, 3 in element of B. So row 2, column 3, 6. And then row 3, column 1, row 3, column 1, 7. And the first row of A, first row gonna be 1, 2. Okay, dimension for matrix D gonna be, how many rows do I have? 2. How many columns do I have? 4, right? So 2 by 4. And dimensions for matrix E will be, how many rows do I have? 1. How many columns do I have? 3 columns. And F will be, how many rows do I have? 3 rows. How many columns do I have? 1 column. No, actually 4 rows, right? Yeah. Okay, so I'm gonna move down and talk about adding and subtracting matrix. Okay, so for in matrices we can adding and subtracting the matrix, and it's only work for matrix that have same size. Okay, so really watch out. Maybe I'm gonna highlight same sign here. Okay, only work for matrices same size, which means same dimensions. And then the mathematical operation work element by element. So for example, A is this matrix here, and B is this matrix here, and if C that is both of them are 3 by 3, right? 3 by 3, and then this one also 3 by 3. That's certified to do the addition and subtraction matrix. So you will have element by element, right? So I will do 2 plus 6 for the first element, right? And negative 10 and 10, right? Negative 10 plus 10, right? And then the next one will be negative 2 plus with negative 2. So I'm gonna minus 2. And then I go to the next row, I say 14 plus 0. And then the next one gonna be 12 minus 12. And 10 minus 4. Because it's adding with negative, so I can just simplify it to be minus. So 4 minus 5. And the next one will be negative 2 adding with 2. And then the last one will be 2 minus 2. So then, okay, so then this is the matrix that we have additions, and we're gonna simplify it. So 2 plus 6 is 8. And then this guy gonna be 0. This guy gonna be -4. 14 zeros. 6. -1 0 and 0. So that is the answer for this addition matrix. Subtraction will be the same. I mean, similar. You do element by element. So so let me just gonna put down 2 minus 6, okay? And then we have -10 minus 10, right? And then we have -2 minus -2. Actually gonna put that like that to make sure I don't mess up, right? I have 14 and minus 4, 0. Then I have 12 and minus 4, -12. Then 10 minus 4 and -4. 4 minus 4, -5. -2 minus 4, 2. 2 minus 4, -2. And after this, you will simplify it. Okay, so let's simplify it. So the first one will give me -4. And then -20. Then -2 plus 2 is 0. Right? And then 14. And then 24. And then 14. 9. -4 and 4. Yeah. So that will be the answer for subtraction. Okay. So sometimes you want to think about like multiplication. So we did have addition, subtraction, and you want to say multiplication matrix with a constant or a scalar. So so we call a scalar multiplication with a matrix, right? And then when you multiply a matrix with a constant, right, you call it a scalar, and every element in the matrix is multiplied by the scalar. So for example, 3a's will give you 3 times 8 for the first element, 3 times 1 for the second one, 3 times 5, second row, 3 times 4, right? So that's gonna be simplified. 3 times 8 is what? 3 times 8 will be 24. And then 3 times 1 is 3. 3 times 5, 15. 2 times 4, 12. Okay. So make the notation of matrix. Okay, with a box like this. So we have answer as 24, 3, 15, 12, right? If we have combination between multiplications, scalar multiplication and additions, we can just follow the operations and do multiply scalar first and then adding the matrix. Okay, so let's have 2b 2b will be 2 times 1 with 2 times with net 2. And then we have 2 times 3 with 2 times 2, right? And adding with 3 times c, right? So 3 times 3, 3 times 1, and 3 times -1. Maybe I move this a little bit. 3 times 4. Okay. So let's move this up. And I will draw the box here, adding those together. So as you see now, if you simplify, 2 times 1 is 2, -4, and this guy is 9, this guy is 3, 6, and then 4, and then -3, and then this is 12. All right, so add them together. Add them up. What do we have? You have 2 plus 9, -4 plus 3, and then 6 plus with -3. Move this a little bit. And then 4 plus 12. Right, and then you can simplify to make the last one. 2 plus 9 is 11. This guy gonna be -1. This one gonna be 3. This one gonna be 16. The answer for this combination will be this guy over here. Yeah. So we have done with addition, subtraction, scalar multiplication. We have one more operation called multiplication between matrix. Right. So we learn about it. Now this guy could be a little bit challenging. So please watch it carefully, and if you're confused, go ahead and do it. Okay, so I have multiplication matrix multiplication between two matrices here and call matrix C. We're gonna be the product between matrix A and matrix B. And you see now, when I write, well, I should have it here. That's a comma here, right? So let's put our typo. Okay, and we're gonna have multiplication between matrix A and matrix B, right? Notice that we have matrix A has the size dimension gonna be 3 row by, let me actually type it. So this is 3 by 2, right? And for the B, you have B is 2 by 2. So they are not in the same size, right? Not in the same dimension, but we have the column, the first one, the number of column of the first one was 2, and the number of column, so number of row of the second one going to be also equal to 2. So you see this guy here, they equal each other. Right. So let's see why that. Do we have any requirement for the multiplication between two matrices? Okay, so conceptually, it helps us to line up the matrix as you see down here. I write as, you know, A first, and then B is like, you know, make it up a little bit on the top of A, right? And then I have C right away below the B. So how can we do it? For C, I will say the first entry is, let's say after product, we have matrix C with 2 column and 3 row, 3 by 2, right? You see that it was 3 by 2 here, 2 by 2 here. So then we need this one is match. We need the row, I mean the column of the first and the row of the second must be matched. For the product dimension, new product dimensions, you will using the first matrix row and the second matrix column to be a new dimension for the product matrix. So we can say 3 by 2. So for the first entry, which is entry 1 by 1 there, right? We will do, say, entry 1 1, right? How can we find this entry? Right? We can use the first row of matrix A, first matrix, and the first column of matrix B to do operations. So let me show you how to do that. I'm gonna multiply between 3 and 5. All right, multiply between 3 and 5. And, multiplication here. And adding, so 3 times 5. Actually, should I gonna use different color? I'm gonna actually use, say, I'm gonna use 3, 1 here. Right? It's come from the first row, 3 and 1. And I will multiply 3 with 5. Come from the first column of matrix B. And 1 will multiply by 7. Right? So we do that for finding entry 1 by 1 of the product matrix. 3 times 5, 15. Adding with 7, give us 22. 22. I may have to have, maybe I'm gonna rewrite this smaller or type together, right? But anyway, let me rewrite this over here. Say 1, 1 will be 3 and 1 here. We have product between 3 and 5, 1 and 7, plus the love. And you're gonna get 22. Next one will be the next one gonna be 1, 2. Let's say that row 1, row 2, column 1, and let's do row 1, column 2 here. So we keep using row 1 this time, but column 2 will be from B. So 3, 1. Time with 9 plus with 1 times 2. That's give us 27 by 2, 29. All right, so I put out 22, 29 for the first row of the product matrix. And then second rows, 2 by 1. We're gonna using the second row. So we're gonna have 8 stick here. Yeah, positive 6, I can put out positive 6 here. That's fine. And then we're gonna multiply between 8 and 5. Use the other color, baby. And 6 and 7. 8 times 5 is 40. 40 plus with 42, only 82. You're gonna use calculator to handle this, right? Okay, and then we have the next one gonna be 2, 2. This will keep using row 2, but second column from B, row 2 in from A, right? So we have putdowns, row 2 is A, and plus 6 here, right? Then we have column 2 from B was 9 and 2. Okay, so this give you 84. Keep doing the same things. You have using the 3, 1. So so row 3 now in matrix A. Okay, it's gonna be 0 plus 4, right? So we have column 1 gonna be 5, 7, right? In matrix B, and you will have what? 28. Next, we have 3, 2, entry 3, 2. So we okay, so entry 3, 2, we're using 0 plus 4, right? And multiplied by 9 and 2 here. So then you will have 8. So put everything in. So 82 should be here. 84. Next one gonna be 28. And then 8 here. Okay, so that is a way we do dimension, we do multiply questions between two matrices. I would love to move this up here before doing example 4.9, but anyway, yeah, that's fine. So as you see, multiplying matrix will be, we'll need to have dimension but agree with following ways as you see that we need to match the column in the first matrix with the row in the second matrix to match, all right? And we can come up with the product matrix dimension is using the row from matrix, the first matrix, and the column from the second matrix is n times p now. Okay, and that will defines the dimension of product matrix. Okay, so down here, I would like to let you practice with multiplications between two matrices. Okay, so you can go by the way that I show you up there. You can, make the first matrix. No, actually, make the first matrix down a little bit, and the second matrix is up a little bit, and then C will be this guy, something like that. Let me see. So 2, -1, 1, 3, right? And this 1, 2, 3, 4. I don't really want to write the equation here. Okay, so this is like a draft. Okay, I want to go like that. 2 times 1. Maybe I'm gonna make it bigger a little bit. 2 times 1. And then plus with a -1 times 2, right? Need more space. So -1 times 2, right? And then times 3, I mean. Right? And then we have 2 2 times 2 minus 1 times 4. Okay, the next row will be 1 plus 3. 1 times 1. 3 times 3. And then we have 1 plus 3 again. 1 times with 2. 3 times with 4. All right. So simplify, you can have 2 times, maybe I'm gonna simplify over here. 2 minus 3, right? 2 minus 3 gonna be -1. 1 plus 3 is times 3. So 1 plus 9, 10. Uh-oh. And we have 4 minus 4, 0. 2 plus 12, 14. So that will be it. So -1, 0, 10, 14. Okay. And I would like to let you try the last one by yourself. So this will be answer key going to be 1, 17, 11, 27, 6, 2, right? Keep in mind that we have, this one is 3 by 2. This one is 2 by 2. So then the last one will be 3 by 2. I would like to give you another one and try it, please. So we're gonna have like 1, 2, 3, 4, and multiplied by, say, 1, 2, 3. 3, 4, 5. 1, 2, 3. Actually, you know what? I can just do only like this. So what is that gonna be, right? So keep in mind that we have 2 by 2 here. We have this one is 2 by no, I want to change a little bit. Change a little bit. I will change this big this. Okay, so I have this gonna be 3 by 2. Okay. And can you do this product? Right? Can't do, because the reason was the 2 by 3. I mean, the first one column was 2, and the second one row was 3, not match. Right. So then we can say cannot do multiplication for this one. Between these two matrices. Yeah. So think about a question that's, if I say, can we have a question? Maybe I'm gonna say I have, let me see. I will actually have the same matrix, but I just switch the position. 1, 2, 3, 4. 1, 2 here. Multiply with 1, 2, 3, 4. Can you do the matrix? So this one is gonna be 3 by 2. This one is 2 by 2. So we will have answers as a matrix 3 by 2. Okay. So that means we still can do multiplication between two matrices in this case, right? So note that in multiplication between two matrices, A times B is not equal to B times A. Okay. I'm going to use ethic actually. So that's going to be it for multiplication between two matrices. However, sometimes it could be really challenged with multiplication between like a big two matrices. How can we do that, right? So I will come up and help you with using calculators for these operations above. I have the direction over here. Okay, everything's have been set up. I will run for you one examples, right? So as you see here is this is direction on entering matrices into TI-83 or above, right? So so let's we start using it. So let me clear this up. Okay, so here's my TI-83 plus. Right, they say I need to click the second and then matrix, which is above the X to power 191 key here. Click on that, right? And then you will see the screen look something like this, right? So you will use the right arrow to scroll over the edit. And you hit enter. So after you get into here, you will have to use to change the dimension of the matrices, right? So you may have to, maybe I'm gonna use the above here information. Last name, the first one is matrix A. And the second one is matrix B. Okay. So I have matrix A is 3 by 2, right? 3 by 2. I have to change the entry down here as 1, 2, 3, 4, 1, 2. Right? And then I move, and then I let's see. So I'm done with this guy. Let's see what they say. All right. So I have so I done with setting up the matrix A. I'm gonna quit, get out of that. So I click second here and go to the mode, which is a quit button here, right? Okay, I get out. And if I want to do something with matrix A, but right now I need to have matrix B also. So I would recommend that do matrix B, name matrix B by the same way above. So click second matrix, all right? And then you go to the edit. You move to number 2 here because you want to do matrix B, and you enter that. You need to edit matrix B to be 2 by 2. Right? Okay, so you have 1, 2, 3, and 4. Right? So I'm done with matrix B. Right? I'm gonna quit. Okay, now I'm gonna do operation between multiplication between A and B. What I do, I click second and matrix again. See the names here. I'm gonna use matrix A. So I click enter. So I got matrix A. And then multiply with matrix B. Click multiply. Then I need to put down matrix B, right? Second matrix name. I see name here. You move down to number 2 at matrix B. Enter that. So you have matrix A times matrix B. Enter that. Okay, so now you have matrix as 7, 10, 15, 20, 22, 7, 10. So put out that, right? 7, 10, 15, 22. Okay, so let me write down. 7, 10, 15, 22, 7, 10, right? So you may say, oh, okay, this is great. Yeah, I agree with that. So I want to check if B times A is that gonna say cannot do multiplication, right? So let's check it out. Second matrix, I do B times A, right? B times with A. See that? It's a dimension mismatch, right? So that doesn't work, right? Good. So now I just finished the way to do multiplication between two matrix, and also showing you using calculator to do operation between matrix. You can also do this on you can also do this to adding between two matrix or anything else, and that should also work. Okay. I would like to split this section to be two parts. So I will later show you solving system of equation using matrices in the other videos. And we'll see you later in the second part. All right.